We are here in Key West, and we are actually at Fort Zachary Taylor. The fort is that way, Cuba's that way, and back behind us you'll see the cruise ship and Trunk Island.
Been feeling trapped down on the floor. I don't know what for. Feels like I'm gone.
We are Diane and Craig, also known as Shorty and Pop. And this is our story about sailing into retirement. As a newly retired couple who loves travel, the ocean, and sand between our toes, we aren't ready to settle down just yet.
And leave me till tomorrow. Wind into my sail. Away from things I let go. Floating on the waves. We go bottoms up. We go all the way. When you're feeling down, push the pain away. We go bottoms up. We go all the way. And things that
We spent like a year and a half getting our boat ready to cruise, and we thought we had accomplished everything that we needed to do. And then we took a week-long cruise from Galveston to Port Aransas. And during that week-long cruise, it quickly became apparent that there were some things that we really needed to do to make the boat comfortable the way we wanted it for long-term cruising. We found out that the battery bank was not sufficient, which meant that we wanted to make a change there. Found out that the iPad was not the way we wanted to navigate from the helm station. And we also found out that our alternator was insufficient. So those are the problems that we needed to overcome before we could take off cruising. This week's episode is a compilation of some of the projects that we undertook. And I think that's the important thing is, what do you need for you to be comfortable? The answer is different for everybody, but these are things that we wanted to make just because it would make life easier. We bought a Balmer high output alternator kit, so it's the whole kit, and it's a 170 amp alternator, and it's externally regulated so it can handle the higher amperage outputs without cutting itself back. So what you get with this kit is you get the alternator, you get all the pulleys to convert from a V-belt, and the problem with the V-belt pulley system, you load them up too much, they slip easily, and they create a lot of dust if they start slipping, which is what we've encountered on this boat. So modern engineering has gone to what they call these serpentine belts. And if you've got a relatively recent model car, it'll have serpentine belts on it. And the reason is because they grip better. They don't have to be as tight, so it's better on the bearings. They grip better because there's more surface area. So it takes a lot of the belt load off, yet is able to still turn the equipment. It also helps with your water pump. Because it's not as tight, it doesn't have to be as tight, it takes the side loading off your water pump, which should help the bearings last in longer. Also, what you get with this is a battery temperature sensor. So this hooks to your battery, and it feeds back to this controller that this is. And this is an external regulator. It's away from the engine. It's a smart regulator. So it will sense my battery temperature. We also got an alternator protection module. But if it senses like a voltage spike, if one of your batteries dies or drops out all of a sudden, then you're going to get a voltage spike off your alternator because it's not expecting that. So it's going to be putting out high amperage. All of a sudden you've lost a battery, and that creates a problem. It can burn out the diodes on the alternator. And then this is a temperature sensor for the alternator itself. And it actually hooks to one of the bolts, and it senses the body temperature, the casing temperature of the alternator, to make sure that it doesn't get too hot. Because if anything gets too hot, you have premature failures. So that's why it's called a smart alternator system. at 170 amps, we should be able to charge our battery bank in, I would say, probably 3 hours or less. So what's undoubtedly considered the best practice is when you're running your motor, load it up. So if we're going to be running our motor to charge our batteries, we might as well load it up. It's better for the engine. It charges the battery quicker, so you don't run your engine as long. So that's the theory. That's the theory in all this. Maybe I'll Google that. So this is the crankshaft pulley for the old V-belt. And so we're switching to a serpentine for the new alternator. These bolt holes right here is what we're going to be bolting to, and those need to be cleaned out, and then we're mounting aluminum to this steel, so we'll have to put some anti-corrosion on there. But first thing I need to do is tap these out because those bolt holes are all rusted. Started chasing the threads on the last bolt hole now. It's been a booger. I finally got all the bolts chased, or the bolt holes chased out. And now I'm just making sure that, since I don't have a bottom tap, I'm just making sure I got them chased out far enough that we can get the bolts to bottom and then get the proper torque on them. Yeah, this will stop galvanic corrosion that results from dissimilar metals. There, that's 25. We're running straight across that bottom crank pulley. Then what you can see is the gap right here where that straight edge doesn't line up. That water pump pulley is setting in too far. So we need a spacer to pull it out and make up that distance there. So I've got the spacer in there. I'll run this bolt in to capture it. And I'll try to put it on. Serpentine belt. So that's what we're shooting for. So again, there's the straight edge on the crank pulley, and it seems to be just about perfect for the water pump pulley. Trying to mount the alternator now. Oh, we're on the last stages of hooking up the batteries. Everything on the supply side of our power, electrical power, has been replaced. So we got all new 4-aught cabling. We got 4 new lithium batteries, 200 amp hours each, so 800 amp hours of lithium batteries that we're just getting ready to hook up the last 2 right now.
We're having a spa day, and it's time to cut Craig's toenails.
I don't know if you could even touch my toenails. Okay, right there.
Ready?
Yep. And a new Xantrex inverter. What we have today is a 2,000 watt inverter, but that's not the reason we're changing it out. It's working just fine. The reason we have to change it out is that we've making a switch to lithium batteries, and the old school inverter charger doesn't have the charging profile to deal with lithium batteries. So that means we had to get some way to charge the new lithium batteries, which meant an upgrade. So down in here, this is a hot water heater, and right up there is the old inverter. The new inverter will charge the lithium properly, but will also give us 3,000 watts of AC. So when we are away from shore, the batteries will provide all of the power, and this inverter can convert the 12 volts to 120 volts AC for a total output of 3,000 watts, which is an extra 1,000 watts, which means Shorty hopefully is going to get to run maybe bread maker and some other kitchen appliances.
Yes. Okay, it's out.
This is the negative wire. This is the negative wire coming off the inverter. And look at this connection. Look. I don't know how good the connection's made, but it's definitely not covered up and insulated. What we took out, we suspected that there was some inadequacies in the belt wiring, and of course we found a lot of things, but probably the most startling thing we found was this was the main battery circuit, main 12 volt circuit. It's a 300 amp fuse. It was on 2-aught wire, which is way overrated. But when we took this apart,
A lot smaller.
this is the new one.
Xantrex.
Maybe I never knew what I really wanted, but looking back I can see it's all clear. I'm still a kid trying to act like they all taught me, but nothing makes sense anymore. Oh, it hurts to grow up.
I had the old style rotary battery switch for the dual bank setup. Because now we have one large battery bank, it allows us to be able to simplify our switching. You remember how confusing it was trying to figure out what did what with those dual battery switches?
Mm-hmm.
So now we're going to have one battery switch. The house loads will go off this one, and the engine batteries will go off these two. So off, on turns the house bank on, and it turns the engine start batteries on. Or you can do both of them. But when we're on, so then the on position, the batteries will be hooked up to our loads, and then this is a 100 amp circuit breaker for the DC panels. But it looks like it's going to fit.
Oh, it hurts to grow up, 'cause nothing makes sense. No, nothing makes sense anymore.
We needed an arch to mount the solar panels and to store the dinghy. We chose Tower in a Box from Atlantic Towers. The construction of this arch is 2-inch OD, Schedule 80 anodized aluminum. When the fit's not perfect, call Shorty. She knows how to give a massage.
It's not turning yet.
Well, we got our main supports up, and then our stringers all put in place. So everything's drilled, greased, lock nutted down. Now we're ready to hang the solar panels, actually mount the solar panels to this rig. So right there we got our main joist going across, and then we got these stringers coming down here. These are 1-inch.
1x1 aluminum.
They're 1x1 aluminum 11 gauge. So they're pretty stout. That was the problem.
Vibration.
And that was just 2 fingers. So with a little down south engineering, we added these struts in here. And now you can see it does. I mean, the whole thing will move, but that winglet's no longer flying free. But it's all mounted up pretty good now, and it's shouldn't blow away in a hurricane. Pretty sunset. That's what 1,000 watts look like.
Because we discovered the iPad was not a good solution because it runs out of battery real quick, and you have to just depend, or we were having to depend on external batteries, keeping them charged to keep our navigation stuff going without having to go downstairs to the helm or to the navigation station. So I told Craig I didn't want to go on any more overnights until we had a chart plotter in our on the helm. So that's what we did.
So what we decided to do was put a second chart plotter on. So we've got one down at the nav station, or the navigation table, and then we'll have one up here, and we'll just run 2 chart plotters. The reason you want one down there is because when the weather's bad or it's night and you're trying to make plans for your passage, your routes and all that, you can't always do it up here because you can't have your books out and your chart plotter and all that at one time. So we can do all our planning downstairs in that chart plotter, but when we're actually navigating, we'll have this one up here to use. And we just like spending money.
Not really.
I was able to move this little pod down and use the existing holes, but this one is bigger, and I can use these 2 mounting holes, but I'm gonna have to drill new mounting holes up here, and then I gotta grind out a bigger spot like this so that we can get cables in and out of it. The cables run down through the pedestal and down into the engine room.
So we have successfully run the wires down through there. Sorry for the lights. And now we have a big wad of wires right here. Were we successful?
You were successful pulling the wires. Now we just got to make all the connections perfect.
Maybe I'll Google that.
We're going to hook the new chart plotter helm. The helm, it's going to be power going to the helm right here on this spare. Looks like it's the last spare. We got cables pulled in. Down to the engine room, we've got our NEMA NMEA 2000 cable. We've got our Ethernet cable. This is the Ethernet for the radar. And this is the NEMA that goes from here around and into this device to pick up these 3 gauges. And then this is our power cable for powering the chart plotter.
And watch for something coming up. Ah, got it.
Okay, well. All right, now I gotta come back down. Try. It's with that DC panel down, it's worse.
Yeah. Houdini would have been proud.
These are soft solder butt connections. So that solder ring is made in there. You put wiring from both sides. And it's supposed to melt at a relatively low temperature. And then you have a soldered joint between the 2 wires. The trick is making sure that the solder melted and then ran down in between the individual strands.
We have depth. We have wind direction. And we have the autopilot.
This is wind.
Yeah.
This is autopilot. This is actually a multi-function display that you can choose a lot of different things to show, but we usually show depth. Depth and speed is what we usually show on it.
And then, pièce de résistance. Da, 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 da. The chart plotter. This one can run independent from the one at the nav station or can run in tandem with the nav station.
First we have to figure out electrical. How to hook 2 wires together and make something work.
We have to have 2 wires that go together
To make something work.
Yep.
That's electricity.
Mm-hmm. That's
It's-
a red wire and a black wire.
Yeah.
Yep.
It's the magic of electricity. Maybe I'll Google that.
If you enjoyed this week's episode, be sure to pound that thumbs up button and subscribe. Leave us a comment, and if you have any questions about any of our experiences, be sure and ask those too. Bottoms up!
We go bottoms up, we go all the way. When you're feeling down,